I do.
It's Christmas.
Merry Christmas.
The seniors pranked our room, so it's very
See the
Christmassy.
ceiling and the-
Yeah, you see this. I ain't cleaning this up.
I ain't cleaning this one.
Happy birthday, Jesus.
It's all gonna fall on you after
It's all
school
Christmas
on
Eve.
Friday. I mean Tuesday before break. Teasing. All right, he's not laughing.
I'll be like,
Zach,
nope.
this is
See, this is
Very-
one of the perks of being like a
All right, is it still on, Emily? Is it still
Yes.
on? Okay.
It's still on.
Hunter, we're reviewing for our mod, is it 5?
5.
Yeah, mod 5 test on Newton's 3 laws. So we started on Friday, and we had to name Newton's 3 laws. Could you bring us up to speed? Name one of them for us. Alex, Newton's 3 laws, what's one of them?
I don't know, there's a lot. I'm just kidding. No, it's the third one.
Okay, what
Third
is
one's
it?
the one, and it's the one if an object. And that's the first one. I'll do the first one.
Okay,
If an object that stays in motion.
if it is
It's
in
motion,
motion.
it stays in motion, and if an object's at rest, it stays at rest.
Right, unless
Unless
acted upon
acted upon by a unbalanced force.
an unbalanced,
outside.
an unbalanced
Action force.
Outside.
outside. I
Force.
couldn't
Outside
think
force.
of it either. An unbalanced outside force. Okay, very good. So that's Newton's first law. Can you recall a second one, Emily one?
Force equals mass times.
All right, that's the easy one. And Emily three. What's another one? The third one.
Every force is equal and opposite reaction.
Right. Okay. We spent a long time understanding that because there's so many misconceptions. So that's the first thing we had to do on our bingo. I'll leave the board as it is and work around this if I can. And so number 2, we did a problem, and we ended up with 300 newtons, but we had to write it as 3.0 times 10 squared newtons. So we'll hit another one like that.
Oh, it's so boring in here.
I know. Draft.
Oh, like, oh, Christmas.
Brandon's sitting there. That's his stuff. So
You can sit here.
we have there and there. There we go. All right. Number 3. So you have your bingo sheet. Anyone need another one? You got
I have
yours?
mine.
Everybody? Where's yours, Alex?
What's wrong?
Guys,
Bingo.
Your bingo
Oh,
sheet?
it's like everyone's, it's Christmas, and you guys are like,
All right. Number
It's still 3
3.
weeks away. Calm down.
You're creating a study sheet, so we just went over the first 2 problems from Friday. So now we are in today's problems. Let me find one for you, Brandon. I have a bunch of them, but when I need to put my hand on it, it evades me. Here's one. Just put on the top that this is review mod 5 and put in some numbers. All right, they catch up to us. All right, number 3. Write the question out again, because, or at least in some sort of shorthand, because we're creating a study sheet. How long have we blabbed here?
Like probably 3 minutes at least.
I'm sorry,
3 minutes.
3
maybe?
minutes,
We'll do
okay.
like 10.
All right, we ought to time it, because sometimes it gets,
Yeah. Should I do it when it gets to like 10? Turn it off.
yeah, that'd be good. 10 or even 9 to make sure.
Okay.
Or you can set that up any way you want. I set it there, but you can change it. A horse and a rider. So if you would draw a horse and a rider. It's a wonder they didn't remove all the chalk except the red and the green. They didn't think of everything. All right, I'll try to write in red and green. Horse. Oh boy, this is going to be really bad.
Mine's
seriously,
so.
the rest of the school is just like, oh my gosh, it's Christmas. Oh my gosh, and then this classroom's just like, it's Christmas.
We have things in the ceiling.
It's too much, dude.
It's
just Monday.
It is 7:54 in the morning,
I don't get excited
and
this early.
They're gonna be
burning
some.
energy for Christmas.
And it's still 55
Brian, we're the
degrees.
Scrooges.
low.
It's
No,
okay.
I was just like, everything, you could just feel like the fresh air outside. When you came in here, it was just like,
This corner is room in the corner
Horse and a
also.
rider. Draw the horse and a rider. This
That's
is
really
problem
good.
number 3.
It's like the constant
Christmas, so it drops below 50 degrees, and then below like 30 degrees.
Wait, what?
It's so warm outside. Like yesterday it was like 55 degrees.
I heard it's supposed to stay warm all summer. I mean, all winter.
All summer. So.
All winter.
So
It's supposed to be
Because
warm
of
on
El
Saturday,
Nino.
which is good.
What's that?
It's supposed to be warm on Saturday, which is good because we're having outdoor day to remember, and so
Outdoor what?
we're having our night for the foster kids, so it's good that it'll be warm.
Yeah, it will be good.
Because
As long as it's not rainy. A horse and a rider in number 3. And it's going to come up against a big ridge of a boulder. And the horse and the rider are approaching it. And when it comes up to this obstacle, it stops almost instantly. Stops very suddenly.
Bruh.
So,
Yeah, my
Stops.
list wag.
so we're going at a quick pace, and then it stops suddenly. Almost instantly. It's a magic horse. He stops instantly. The question is, what happens to the rider? And which law does that is that indicating? Horse and a rider walking along, or actually going quite quickly, at quite a clip, and it stops suddenly. What happens to the
My horse is a
rider?
dinosaur.
So we've all been there on a bike or even in a car where it stops suddenly. What happens to our bodies? Brandon, what happens in our
Keep on going
bodies?
forward.
It goes forward. Emily, what law is that?
Oh, yeah.
Newton's third law, the
Should buy a horse.
an object in motion tends to
All
stay
right.
in motion.
So law number 1.
Or one.
1. F equals MA. So law number 1, the one that Alex spoke out earlier about I'm going the wrong way. When an object's in motion, it stays in motion. And so this is why the object and the horse had the same velocity. When the horse stopped, the person still had the same velocity and continued forward. All right. All right, number 4. Oh, if you got that, I'm not putting up the bingo thing. I have one here in front of me, and because of the board space. G2. Remember on Friday, I crossed out G3 and O1, so we're on G2 now.
Wait, and why are you gonna say, can we have the same board?
All right, the next one. Draw a truck.
Oh, jeez.
A truck. Draw a truck.
Got party people.
Mine looks like an old-time
Next
truck.
Saturday.
19.
Trucks used to look like that. It's 921 kilograms. The truck is 921 kilograms. It's accelerating down the road. So not only is there a velocity, the velocity is changing and increasing. It's accelerating down the road. So I'll just say accelerating. Mu sub k is 0.39. Mu sub s is 0.29. And the force of the engine provides a force in this. It's 4,987 newtons. So I'll add that to my picture. 4,987 newtons. Guess what I'm going to ask? Think of all the parts that are already known.
What's the force?
I have the force of the
What's
engine.
Oh, the acceleration.
Right, find acceleration.
Miss Powell, isn't M sub S supposed to be larger than MK?
Oh, did I finally do it wrong? You're right. That's what I have on my paper too. All right,
I mean,
we have
I'm-
to switch those. We have to switch those. 2 hands up. I said I would do it one day, so I held you to the last day. So MS is 0.39 and MK is let's since in the equation we need which one, Emily, number 2?
Mu sub K.
We need mu sub k, and since I used 0.39, let's leave this 0.39 and just increase this one to 0.49.
Okay.
We don't need it anyway, so thank you though. Notice MK is always, mu sub k is always less than mu sub s, and we'll review why that is in a few questions. So, all right, find the acceleration. All right, so it's been a while. Did you watch the video on these kind?
Some of them.
Okay, some of them. All right, so there's a basic formula, and that is the force, the sum of the forces equals MA.
But then you don't have the
So you can overhear Brandon and I if you don't remember where to start. Sum of the forces is MA.
Good.
So there's 2 forces. One this way is the force of the engine, and 1 this way is just a force of friction. The force of friction always opposes the force of the engine. So I'm going to call this positive and this negative. So I have force of the engine. This is a summation sign. So force of the engine plus a negative, so it just becomes negative. Force of friction equals MA.
Okay.
Now, the tricky part, everything else we kind of just plug in numbers, but force of friction, we have to know that the force of friction is either mu sub K or mu sub S. If it's moving, it's K. That stands for kinetic.
Yes.
So it's this one's moving, so we're going to grab this number, 0.39.
Multiply that by.
So 0.39, and then it's followed by force normal. Force normal is, if you recall, I think you were here for that, when there's a platform, weight is down and force normal is up. So force normal is mg, but it's going to be positive. So the weight of the object.
Should I?
So, oh yeah, you want to show? It's not going to show up, I don't think. Force of the engine is, can you pick
You're
out
good,
the
Brandon.
force of the engine from there?
3, 9.
I did something wrong.
And
Yeah, I
then
didn't like negative
you have
numbers.
force-
I'm not.
You have force normal, which
Force
is
of the
mass,
engine
which
is
is
given.
weight
Yeah,
times
19
gravity.
It was given in the
Mass
problem,
is
4987.
times gravity is
So
5.8.
4987. Force of friction is a tricky one because it involves all of this. So what's MK?
29.
And then M. The mass is
2.9.
921. That's when you see kilograms, you know you're working in mass.
Gotcha.
And G is the acceleration due to gravity. It's hard to read this.
Oh, wait, Brian.
Yeah, but because it's force normal,
3.8?
M says
it's
4,000.
up. It's we're gonna use the positive
Divide
9.8
by 2.
equals M.
Same problem.
That's the mass again.
Right.
921. We're up to here.
You got 1.8?
Equals an acceleration. So we're solving for that. So just calculate that, subtract that, and divide by that. All right.
Where'd you get 9026?
Wait, Miss Cal, is it 4.97?
Yeah. No. 4,000.
That's what that was. Yeah, hold on, give me a second.
4,987 newtons.
I was like 9026, 921.
Who's got any? Well, I'll just tell you.
Wait.
All right. So some of the forces. I'll just start it, Emily. Try to beat me.
Yeah, I'm
Some of the
Oh, I got
forces, there's two forces, force of the engine, and it's going to be opposed by the force of friction. So there's only two forces that are net. Force of the engine is known. Force of friction, force of the engine was the 4,987. Force of friction is mk, because it's in motion, mu sub k, times force normal. Force normal is positive upwards, and it's equivalent to the weight. So it's just mg. So we'll come back there and grab those numbers. So we're looking for acceleration. We know everything else. 4987 minus mk is 0.39. mg, m is the weight. Remember, if it's in kilograms, that's the mass. So we have 921. 9.8, notice I'm using the positive 9.8 because it's force normal upwards, positive number, equals mass, which is again the 921, times A, solve for A. Oh, what's that?
Okay, I see what I did.
Alright, so you multiply all this together, subtract it from that, and divide by that. You ready? What did you get? Acceleration equals 1.6 meters per second squared. Anyone?
I rounded it to 2.0.
Why would you do that? What did you get before? Anyone get that?
What?
1.6? Did you?
I should have got
Yeah.
1.6. I did everything right except for I thought 4,987 was the weight and not the.
I don't know why I rounded it to
It's a force of the engine.
Yeah, I noticed that. I thought it was the weight for a minute. And then
Alright.
I was,
Alright, weight is in newtons, but we weren't given the weight, we were given the mass, so we had to go with mg. All right, if you got 1.6 meters per second square, you may cross out N4.